Okay, well, good morning, everyone, and welcome to the December edition of the Ag Economic Dialogue session. We have a great lineup for you today of some pretty good speakers from across the state today. We're going to start off with Tong Wang. She's going to talk about some of the research she's done with producers changing practices due to different climate changes. Jack Davis is going to share some information on research data that was done on different cropping rotations and profitability. And we're going to wrap up with Darren Clabo. I hope I said his name right. He is filling in for Laura Edwards for us today. He's the state fire meteorologist based out of the School of Mines. So we will enjoy all of them today and their presentations. If I could have everybody fill this poll out so that we make sure we get a head count of what's going on today, I would appreciate it. Just give you a couple seconds here. Click some of those buttons as you go through. And then we will turn it over to Tong and she can take over for the day.
So I will start. So my topic is like the farmers' perceived extreme weather frequency in South Dakota and their adaptation measures. So I did that from a survey we take this summer, actually. So let me start. Oh, why this is not moving? I think that's, oh, okay, good. So the motivation for our research is we know that the weather pattern in South Dakota has alternated between the drought and the flooding. And there is a recent increase in the frequency of extreme weather events. And every time there's associated economic losses with those either flood or drought. So there has been some adaptive responses from the farmers to prevent and mitigate the losses. So I try to find out how South Dakota farmers, their perceived prevalence of the extreme weather events and their perceived losses and their future plans to take those adaptive measures. So that's the motivation. And so what we did is from the four step of the survey. So first of all, we sent out the advanced letter with a $2 incentive with the links of the online survey. And then we sent out the first round of paper survey with a return envelope and a postcard reminder, and then the second round. So the 2021 survey is actually based on the sample that responses we received from the 2018 survey. So 2018 survey, we received 708 responses, and this time we got 350 out of the 708. So it's kind of 59% response rate. So that's the survey method and response rate. So here I just show you a distribution of our the farmers in the different counties. So you can see that these are the eastern South Dakota counties, and so basically we receive more surveys from the counties we send out more survey to. So this distribution actually is a reflection of the number of surveys we send out. So that's those counties where the corn production has been concentrated that we send survey to. So with this, we got the responses from the farmers because we asked them like how many extreme weather events like drought and flood, how many have you experienced during the past 10 years from 2011 to 2020? And so very few people did not experience any of them. So we found like 2% of farmers did not experience any flood, and 13% did not experience any drought. But the majority of farmers, like 63%, experienced 2 or 3 years of severe wet conditions in their county where their field is located at. and 41% experienced severe drought in 1 year, and another 41 experienced severe drought in 2 or 3 years. And very few experienced drought. Only 5% said they experienced drought in 4 or 5 years, and 16 of them mentioned that they experienced severe wet conditions in 4 or 5 years. So the majority of the experiences with either drought or wet conditions focus on either 1 year or 2 or 3 years. So based on the farmers' experience, we also look at the South Dakota, the state average drought and flooding conditions from 2011 to 2020. So here is the figure showing that actually the flood and drought conditions actually alternatively showing one of another. So we can see that it starts with a, so here the blue color is the flooding events, and the red color or close to red color is the drought events. So we can see that it starts with a 2011, extreme weather event, wet events, and then it turns into the drought, and then turns again into a wet condition and a drought. So it's kind of goes just one after another. So there are some events that is most severe than the other. So I think the differences in farmer responses might be some farmers account for some minor drought events also as a drought, but some people might not only count for the severe drought. So that's maybe account for the differences in farmers' response. So in the way that we see the state average weather fluctuation pattern, we can see that the farmers' perception is in alignment with our state level weather conditions reported here. And we ask farmers how much they are concerned about the weather conditions. So 2021, we found that most farmers are worried either moderately or a lot about not enough rainfall. So I think that's because this year is a particular drought year. So 79% of farmers worry about not enough rainfall. Only 4% of producers indicated they are not worried about that. And so 63% worried about too much rainfall. So I think because of this year, maybe in different years, farmers' concerns about different events will be different. So we see more people experienced more flooding than the drought, but in 2021, we see only 63% of producers worry about too much rainfall. And 8% of producers indicated that they are not worried about too much rain here. So we also look at the producers' rated impact about the most recent flood. So this, I think most people might thinking of the 2019 flood that they have experienced. So we divided people's into 3 categories here. So one is that 0% of their fields is not planted. So which means all of their fields are planted. And this one is 1 to 60% of their fields is not planted, which means that 40% is planted, up to 40% is planted. And this one is 61 to 100% not planted, which means less than 40% of their fields is planted. So this goes this way is becoming worse. And we also ask people to report for their no-till fields and ask them to report for their conventional tillage fields. So we see that for the most recent flood, we did not see much difference if we compare only those 2 practices alone. So we see that actually the no-till fields have more of their more farmers have all of their fields planted. In that 13% have their fields, all their fields planted versus 11% for the no-till farmers. For the I mean the no-till versus the conventional tillage fields. So it's 13 versus 11%. So there's a 2% increase in the farmers who have all their fields planted. And for the rest, I think is only 1 or 2% difference. So is from this figure, we really cannot see much about the role of no-till in reducing the damage from the most recent flood. So we took a look at another one that is, okay, I will show that later. So here, first I look at, okay, so what is the practices taken for the fields affected by the flood? So we see that actually 59% of the farmers left their field idle, so did not plant anything for that season if it's severely affected by flood. And another 44% of farmers indicated they planted cover crops. So because the farmers can choose multiple options, so they could choose that either option. So some of them did not plant any cash crop, but meanwhile they planted some cover crops. And we also asked them whether they did the cover crops with government assistance or on their own. So 37 planted cover crops on their own, and only 7% did so with the government assistance. So together we found that 44% of farmers actually planted cover crops on the fields that had been affected by the most recent flooding events. So this is the most recent drought. So for the most recent drought, we found that we look at farmers' yield compared to the normal yield, because in the drought, they most likely planted all the fields, but the yield will suffer from a loss. So we see that for no-till and conventional tillage fields, 6% of farmers reported they have no yield at all. So that's the 6% here. And we have 66% reported went to 60% of normal yields, and 71% of the conventional tillage field reported went to 60% of the normal yield. So here in this category, we can see the conventional tillage fields has exceeded the no-till fields by 5%. And this last category is the best category where they achieved 60 to 100% of the normal yield. Here we can see that 28% of the no-till fields achieved more normal yields than the 23% of the conventional tillage fields. So in this regard, we can see that tillage actually has helped with the yield in a drought year, in that more percent of the producers with no-till fields actually have achieved the good results with the yields. So even that in a drought year, we can see that only less than 30% of the farmers in either category have achieved near normal yields. But tillage, the category does not help in this one, and no-till, we can see that it has a better result. So here I compared the no-till and tillage. So only the no-till farmers actually, and the duration of no-till and their drought year yields. So I break the no-till farmers into 4 categories. So those who use for less than 3 years, who use it for 3 to 5 years, and 6 to 10 years, and 10+ years. And we look at their reported drought year yield category. So here we have 1, 2, 3, 4. This 2 here means 1 to 40% of their normal yields. So that means in a drought year, they achieved 1 to 40% of the yield compared to a drought year. And 3 means they achieved 41 to 60% of the yield compared to normal year. So as the number goes up, basically they got more yield compared to the normal year. So basically it's in comparison with their normal year yield. We can see that it's very two similar patterns here. One is the less than 3 years and 3 to 5 years. So those two group of farmers reported a percentage of yield of around 2.57 or 2.56, which is right between 2 and 3. So I think is those farmers achieved right above 40% of their yield during the drought year. And another two groups that shows similar pattern is the 6 to 10 years and 10 plus years. So those farmers actually achieved either slightly above 3 or nearly 3 here. So 3 means that 41 to 60%. So here we can say that even with no-till, the duration does matter. So we can say after 5 years, producers actually in a drought year, they observed a higher yield, which is more close to normal years. I observed this trend for the drought years in the yield pattern, so that we can see that as producers use a no-till for more years, they produce a higher yield. However, I didn't see this trend for the extreme wet years. I didn't see that they have less or more fields planted because of no-till. So I think in that sense, we can see that no-till has more role to play in a drought year than in a wet year in this region in eastern South Dakota. So that's what we found with the duration of no-till and drought year yields. So we asked about the producers about, if your conventional fields has been affected by extreme weather, or you think will be affected by extreme weather events, what's your plan over the next 5 years in using the following practices? So we listed those 4 practices and asking people about their opinions, either very likely, somewhat likely, and unlikely, and very likely. So the very likely, we use the dark green here, and likely is lighter green, and somewhat likely is gray. So we can see that among the first 3 practices, if we count all the likely categories, all the 3 likely categories, we can see close to 70% of the producers, they are likely to use either very likely, or somehow likely to use the first 3 practices. Only integrating grazing is not that popular compared to the first 3, in that only 50% shows their to different degrees of likely to adopt this practice. So that's their plans over the next 5 years. And then I divided the producers based on their perceived drought prevalence and their plans to adapt. So there are different categories here. Here means the none of the years have been affected. 1 year has been affected by drought, 2 or 3 years have been affected by drought, and 4 or 5 years have been affected by drought. So we can see that for each of the practice, so the first one is for the no-till, the second one for the cover crop. So we can see for each of the practice, as farmers say that they experience more years of a drought, they also have plans to adapt to this drought by adopting different practices. So on the vertical bar here, we have either unlikely to likely. So 2 means unlikely, 4 means likely. So this is the average response. So no average response actually goes to 5. So I just listed from 2 to 4 here, but we can clearly see the trend that as their drought years, their perceived drought years increase, their plans to adapt also the likelihood of adopting those practices also increased. So this is for the tillage, and then this one is for the cover crops. It's a slightly different pattern. Some increase by a lot, but some increase by slightly differently. But we can see this clear pattern that with the category, there is either a slight increase or a big increase and across categories. And I also look at the other 2 practices for the diversified crop rotation and integrated grazing. So even though the likelihood varies across the practices, but one trend is clear that if producers perceive more drought, then they are more likely to adapt. This is a pattern we observe from the drought prevalence, but there's no indication of such pattern from the flooding perspective. So that's why I only presented for the drought here. Another thing I took a look is the cost share received for those practices. So I asked the producers, either they receive no cost share, CRP, CSP, EQIP, or the other. So we can see for all the practices, the majority of producers have not received any cost share. Even the cover crops where more than 30% have received the cost share, but we can see still 65% did not receive any cost share. Also, I compared is the no cost share and the received cost share. What's the percentage of the cover crop acres? So whether the cost share have increased different, because we ask, for example, if you use the conservation tillage, so on what percent of your land you use conservation tillage? So we give at 0%, 1 to 20%, up to 81 to 100%. So we can see that different practices people use on different percentage of their land. For example, the cover crop here is used on the least percentage of their land. It's only between 2 to 2.5% here. So I try to see whether producers receive a cost share actually planted on more of their land than the people who did not receive a cost share. So we did find this pattern across different practices. So it turns out that people receive a cost share did use the practice on a higher percentage of their land compared to the producers who did not receive a cost share. So different practices, we have various responses. For the cover crop, we can see clearly that cover crop cost share actually helped the producers plant cover crops on higher percentage of their land compared to those who did not have cost share. So in that way, we can say that even though most people did not make an effort to obtain cost share, but cost share actually will help farmers to use the practice on a higher percentage of their land. So the conclusion we have for this one is, so we can see that most farmers experience severe weather events in their county over the past 10 years, either for 1 year or 2 or 3 years. And farmers reported negative impacts on their agriculture output due to drought and flooding in terms of reduced yields and the unplanted fields. So we can see that compared to the short-term no-till users, the long-term no-till users suffer less from the yield loss during the drought events. So we also say that farmers are responsive to extreme weather events through their planning of using the conservation practices on conventional fields. And we do see that the farmer who receive the cost share will be more likely to use it on more of their fields. Okay, so that's the end of my presentation. So if you have any questions, feel free to let me know. Thank you.
Thanks, Tong. We appreciate that. We will do questions at the end so that we make sure that we try to get through everybody's presentations today. We will have Jack go next and present his information to you, and then we will get to our weather update.
Okay, well, we looked at different cropping patterns. Pete Sexton has some long-term research from the Southeast Farm and also Dakota Lakes on different yields that have taken place with different cropping situations. We'll go through this. And sometimes I advance and sometimes not. Just we wanted to share what oat acreage had done over the time since we started planting oats, and you can just see how it really fell off as probably some of the commercial fertilizer came into place in the early 60s, and then just other technologies and the demand for corn and soybeans and the ability to grow them in South Dakota and the US had dropped off oat production, so a small grain production in general too. Then just looking at all planted acres, I'm just going to go through this fairly fast here. The other thing would be corn yields in South Dakota and how they have increased. Again, you can see that space where the commercial fertilizer came in, it started to take quite a jump, and yields have just increased about 2 bushel per year. So some of the benefits that we can see from this, as you can read there, disrupts the weed and pest life cycles, provides more diversity to the roots, and protects the soil and soil health situations. It can decrease cost, maybe not quite as much cost for some of the pesticides that we would have to use, and also open up other income streams, make better use of machinery and time, labor resources. And some things you want to watch for is that you have, if you're taking on a different crop, that you have market that you can deliver to. So the ones that we looked at, we just picked corn and soybean as our traditional, and then added corn, forage rye, and forage rye, then double cropped with soybean. Looked at corn, soybean, and hybrid rye or winter wheat. And then one that's become popular or starting to become popular is what we'll call a stacked rotation, where they do the same crop 2 years in a row and then do a split on it. So corn, soybeans, throw in rye, a hybrid rye or winter wheat 1 year, and then soybean, and then back to a corn. This based on 25 years at Southeast Farm, 17 seasons in the stack at Dakota Lakes, and then used information from a study in Nebraska, and then a 10-year study in Iowa. Also some communication with our soil scientist that also farms in the eastern part of the state. One thing you want to be careful on, that rye and wheat are incompatible. They do not work together. Especially if you're growing seed wheat, or if you have a neighbor that's growing seed wheat, you want to be cognizant of that when planting rye, because that can contaminate the wheat and they can cross, and that's just not good for somebody that's producing seed. So in the corn forage, rye and the double crop soybean, we would consider our corn yield wouldn't really fall off. Forage rye can produce anywhere from 1.5 to 3 tons per acre dry matter, and that's from our southeast farm. And the soybean yield's going to drop a little bit, kind of a 98%, about a 2% drop if adequate moisture and able to plant it on time. So those would be some considerations. You know, if it ends up dry and you still want to take that forage, you might want to look at doing something else versus trying the soybeans that year, because it does. If we end up dry, it really falls off hard. So just some considerations in that rotation. So now looking at the corn, soybean, and then hybrid rye or the winter wheat following the soybeans, we do get a boost in corn yield of about 6%. The earlier bean to get our rye in, after our first year or so of first pass through this rotation, that soybean yield probably comes out to be about 100% of a corn soybean yield. So some of the benefit from a longer rotation makes up for that use of an earlier soybean. In a hybrid rye, we used a target yield of about 110 bushel. That's what they've been able to achieve at our southeast farm. And then you have the advantage for mixed operations to add a cover crop on the end of that. And our average dry matter weight was, as you can see, 2,500 pounds. So in the stacked is where we probably get more of our benefit, plus we have more corn and soybean acres altogether versus some of the other rotations. So we can get a pretty good boost on that first one. We do drop off maybe somewhat on the second one, and it really becomes key in picking the right hybrid. So you want a corn that is good following corn, and maybe more of an aggressive one on that first year. You'd want the high yielding and take advantage of those other things that have been put in place. We do see a boost in soybean yield with this also. And then there's what we would expect from our hybrid rye. And the second year also, our second round of soybeans also sees an increase. So just some budgets, and the two different ones where we can get the rye in early, we can see that 3.2 tons, and where it's a little later, not getting it in the fall, it's going to drop off a little less. I just took what we expected for a dry matter yield and used it as grazing. That's how we're valuing it here. And at a 2.5 intake of body weight, grazing 1,400 pound cows on it in the spring, and using $1.75 as our grazing rate, and then listing the cost. This is also then that we were able to follow that rye with a forage crop, and this could also be the wheat too. And there would be our value that we could achieve from our fall cover crop. We get a little more grazing, it's a little more palatable in there in the fall. As our utilization rate is showing, we bump that up to 60% versus a 40%. That's showing the same thing. And looking at rye versus wheat. some reason I can't see all of my screen. Got this. Sorry about this, guys. Oh, one of those days. We're going to go forward. Here, looking at rye grain versus winter wheat, and just used if we were planting it this fall, so 95 cent for nitrogen, assuming that we put it on when it was high priced here, a winter wheat yield of 70 bushel. So in this year we had it would actually favor winter wheat with a higher price due to in our winter wheat, but even with the higher priced nitrogen. And then looking at last year when they were about half price, at least on the wheat, and nitrogen was half priced, it favored rye. So just things to think about, but also then keep in mind that you don't want to mix the two on a farm. If you are growing wheat for seed, or you maybe have a neighbor that's doing that. Okay, so just looking at an example of a 2,000 acre farm, a corn yield starting out at 170 and soybeans at 47. So that would be our long-term average yield with those two. Forage rye at the 1.5 to 3.2 ton. So I just split that in this example for our forage rye. And the hybrid rye was at 110 and the cover crop was at the 2,500 pounds. So just listing the amount of bushels that we would get, tons available here, bushels of hybrid rye, and then pounds of dry matter from our cover crop on a 2,000 acre farm. This is corn first year, soybeans first year, corn second year, and soybeans the second year, and then the totals. So then looking at it revenue wise, and I think just thing I want to point out maybe is that we're at $1,038,000. I was just using prices from 3 weeks ago when we put this together. So we just picked a fall price on that and ran with it for this example. But not much fall off between that corn soybean rotation and our stacked rotation, which its total is down here. And that's probably the one thing that I wanted to point out. And then using costs that used our budgets and didn't change it for maybe some lower costs due to rotation, didn't change those costs at all, just used it standard across there. And we did net out a little better with the stacked rotation. Things to keep in mind is, do you have a place for that hybrid rye or whatever small grain that you might be putting in there to sell? Now this is the same stuff, just blown up for presenting it live. So in summary, the corn, rye, soybean, and a double crop kind of maintain that current grain, does provide forage. Things you got to watch is drought and late planting of soybeans. So you might want to, if it's ending up dry in the spring, you'd want to consider how much do I need that forage, maybe spray it out early if you wanted the soybeans. You do get advantage of weed control, straw, manure application, and grazing in a corn, soy, hybrid rye. And again, remember, you can't do both. You don't want to do both. Stacked rotation, minimal change in our acreage, weed control, all the benefit of straw, manure, grazing. You want to be careful, as I said earlier, picking those hybrids. So you want, on that second year corn, you want to pick something that does good following corn. And we're finding that the rye it's an up and coming crop, hybrid rye, and it's being used quite a bit in swine. diets, and they are buying it readily for that. But you would want to make sure if you were going to get into that you had a place to sell it. It runs about 85% of corn as far as a selling price. That's been pretty consistent. So that's what I have.
Super, thanks, Jack. Like I mentioned earlier, we're going to do questions at the end. We'll turn off the recording and you can ask your questions at the end. So with that, Darren, I will turn it over to you if you wanted to share your screens and take over.
Surely. All right. Well, good morning. My name is Darren Clabo. I am a research scientist at South Dakota Mines, and I'm also the state wildfire meteorologist for South Dakota. Yeah, Jack and Tong, those are wonderful presentations. That's really interesting things that I don't often think about, especially you, Jack. I don't often think about egg prices in my world. Tong, I think we need to have a longer discussion because some of the work that you're doing is very close to the work that I'm doing. So today, Heather asked me to put together a presentation just looking at the climate and weather outlook kind of over the next few months and then looking at next year. But during Tong's presentation, I actually changed mine around because I found something that's pretty interesting. So I have 3 graphs on here, and this is all for southeastern South Dakota. But this top left graph is the maximum temperature during the growing season, so April through September. So we're looking at maximum temperature each day and kind of averaging that out. Top right is minimum temperature, so the overnight minimum temperature. And then the bottom graph is precipitation, and this goes back from 1895 to present. The interesting thing here is that our maximum temperatures over much of eastern South Dakota are actually decreasing over time. However, the minimum temperatures are greatly increasing over time. And this is because we're actually seeing higher humidity levels in the atmosphere. And I think a lot of this has to do with land use change and conversion from prairie to row crops across kind of the greater upper Midwest. And that's also leading into an increase in nighttime precipitation, which is my bottom center graph. And so just thinking about Tong's presentation and that there are more farmers worried about drought, I think if we look out into the next decade to 3 decades, we're actually going to be looking at an increase in precipitation events, maybe higher precipitation events. So just something to keep in mind that we are trending towards a more humid climate, which is boosting our overnight temperatures while decreasing our daytime temperatures a little bit. We're still warming overall, but that trend is really seen overnight. So I thought I'd just share that with you because it struck me as interesting in relation to what Tong was discussing. So that was fun to see. So getting into my presentation, which shouldn't last more than, I don't know, an hour or two, I kid. But we have our winter outlook, where we've been, where we are now, and where we're headed. And the image I have on here is actually the big storm that we saw 2 days ago. Big upper level low pressure system centered over northwestern Kansas. They had a big dust storm down there, some huge fires. And of course, as that storm system moved off to the northeast, we had tornadoes across Iowa and Minnesota and a lot of wind across the region. And a lot of places in eastern South Dakota saw lightning and rain and thunderstorms, not things that we typically see in December. So climatically speaking, this storm that we saw 2 days ago was way out in left field. Looking back to this last summer, this is April through September temperature in terms of the statewide averages across the United States. South Dakota registered somewhere in the top 10 warmest growing season on record. And again, these records go back to 1895, so it's an average of 127 years. Western United States was the warmest, and I think the wildfires we saw on the west coast and the Sierras really told the story of those warm temperatures. But by and large, it was warm across the northern Great Plains, a little bit cooler than average, across the lower Mississippi River Valley and going into the southeastern part of the United States. If we look at precipitation, again, during that same time frame, April through September of this last year, much wetter than average across the south. Mississippi, Louisiana had their wettest years on record. There were several stations in Mississippi that actually reported over 100 inches of precipitation, which is more than double their annual average or close to double their annual average down there. So extraordinarily wet in the lower Mississippi River Valley. New England country was wet, but then if you go up into the upper Midwest, northern Great Plains and the Pacific Northwest and California, very dry once again. We just didn't see the storm systems coming through. And, you know, those dry conditions really revealed themselves as pretty extreme drought across the northern Great Plains, the Dakotas, and up into Montana. And interestingly enough, in October, we did get a little bit of precipitation. November got a little bit of precipitation. And I thought North Dakota was going to register one of their absolute driest years on record, but it didn't shake out that way due to some late season precipitation. But we were kind of in the bottom third in terms of overall moisture. If we look over the past 60 days, really middle of October through present, it's been exceptionally warm. This is a picture of departure from normal temperature across South Dakota. All the dots are warmer than average that you see, those warm colors. You know, Western South Dakota was 6 to 10 degrees above average. And if you extend that over a 60-day time period, I can't stress that's extreme. That is a lot of heat this time of the year. And even Eastern South Dakota, looking at 2 to 6 degrees above average, very abnormal for a 60-day time frame. Precipitation anomalies over the past 60 days. Eastern side of the state's been relatively wet, and that's really where we've seen the kind of alleviating those drought conditions that we had coming from the summer. Western South Dakota, Northern Black Hills, by and large, average to drier than average. Northwestern South Dakota has definitely been drier than average. Northern Black Hills, you know, Terry Peak has only got 3 or 4 slopes open right now out of whatever, a couple of dozen slopes that they have. There's just not a lot of snow, not a lot of precipitation going on out here. But a lot of the green dots that you see on the map over West River looking south of I-90 are actually from that snowfall event we had be a week ago today, or a week ago yesterday. Hot Springs country picked up 15 to 20 inches of snow, which shook out to be between, you know, right around 1.5 inches of liquid equivalent moisture. So great precip, which boosted their average over the past 60 days. And then of course, Eastern South Dakota has gotten a lot of precipitation. Southeastern South Dakota saw that snow last week, and then all of Eastern South Dakota did get some precip out of the system that we had 2 days ago. So definitely a lot more moisture over the past 60 days than we saw this summer, which is a great thing for ag, because now we're starting to lock that moisture into the soils. As the soils start to freeze, that moisture will be available for spring germination next year. Our current drought monitor, we saw a lot of improvements in the drought monitor this week, especially over southern South Dakota, kind of along and south again of that I-90 corridor. Much of the area saw 1 category improvement, going from D2 to D1 or from D1 to moderate drought. But most areas are still relatively dry, and that's especially true for the northwestern quarter of the state. Northeastern South Dakota, on the other hand, they've been seeing, again, those precipitation trending upwards over the past 60 days, definitely been wetter than average in those areas. Our 8-week change in the drought monitor, again, mostly improvements across the state, or no change. North Central South Dakota did see a little bit of degradation over the past 8 weeks, which is kind of some short-term dryness that they've been seeing in those areas. So let's look out next couple of weeks. This is in the near term, 8 to 14 days. There's a pretty strong signal that the southern United States is going to see warmer than average temperatures going through kind of the Christmas time frame, maybe into New Year's. We're getting the jet stream setting up across the central part of the United States, which is pushing all of that hot air to kind of warm up the southern Great Plains, but it's also allowing a lot of Canadian cold air to dump into the northern Great Plains. And of course, South Dakota is right on the border of that. So I do anticipate over the next 8 to 14 days that we are going to see, you know, kind of this pattern of warming and cooling as these weather systems move in. And associated with that kind of warming and cooling, I do expect, you know, a few fronts to come through, a few low pressure systems to come through. And if we look on the right-hand side, due to that pattern change, we should see at least average precipitation, if not trending towards a little bit above average in the near term. That's not saying much. The end of December is not known as our wet season in South Dakota, so it's not a lot of moisture, but hopefully we can get some snowfall. We can cover the ground up to ensure that the moisture that's in there in the soils stays in the soils. Going out a few more weeks, cooler than average conditions. There are some kind of climatic signals right now that are pointing towards colder to much colder than average conditions across the northern Great Plains. Jet stream kind of dips south. Polar vortex terminology might be coming back into our vocabulary in the news media. And then associated with some of those frontal systems, we do expect at least average to, if not above average, chances for precipitation as seen on the right with those green colors. So looking ahead, we're currently in a La Nina. and we're expected to be in a La Nina at least over the next 4 to 6 months. There's some tendencies for the models to show maybe back to an ENSO neutral. When I say ENSO, I mean El Nino, Southern Oscillation. It's this pattern, of equatorial Pacific waters that warms and cools, and it affects our area up here. So right now, La Nina situation just means that the Eastern equatorial Pacific waters are colder than average. And it basically just messes with the jet stream and tends to affect our weather here in the Northern Great Plains. And so on the right-hand side, we have all the La Nina situations really over the past 60 to 70 years. Most of these times we're in a strong La Nina. We get cooler than average temperatures across the Northern Great Plains. But these cooler than average conditions typically poke their head up kind of like late January into mid-March. Typically conditions this time of the year aren't really affected too much by La Nina, but in most La Nina years, we do get colder than average conditions during the winter months across the Northern Great Plains. The big outlier here was the year 2011, 2012. And remember 2012, we had extreme drought across the state. My world was rocked as a fire meteorologist because we had wildfires all across the Northern Great Plains and the Northern Rocky Mountains. And the other interesting thing about 2012 is it was what we called a double dip La Nina year, which means that it was a La Nina year that followed another La Nina year. That's the same situation that we're in right now. Last year was a La Nina year, and we saw drier than average conditions during the summer. This year is a La Nina year, and so I'm not saying that we're going to get a repeat of the drought of 2012, but I do want to put that out there that, looking at a 2011, 2012 winter is an analog to what we're seeing now. I'm hopeful we don't see that again because that was a very extreme year, but it's just something to keep in mind. And if we go into wintertime precipitation, La Nina winters really don't do much in terms of give us more or less precipitation. It typically affects the Pacific Northwest and kind of the Ohio River Valley more than it does us. So again, typical La Nina years, cooler than average temperatures, near average precipitation. These double dip La Nina years, we might be trending towards kind of an opposite of that, warmer than average conditions through the winter. So there's just, let me put it this way, looking at La Nina alone, there's not a lot of predictability, but we do consider into some other oscillations, but I don't really want to dive into that. So looking towards the experts, the Climate Prediction Center from the National Oceanic and Atmospheric Administration, this is their 3-month outlook. They're hedging their bets towards below average temperatures across the Pacific Northwest, equal chances of above average or below average temperatures across most of our area, and they're expecting a warmer than average period over the Southern Great Plains going up into the New England states. Looking at precipitation on the right-hand side over the next 3 months, kind of above average precip in Northern Rockies, Pacific Northwest, above average precip over the Great Lakes and the Ohio River Valley, and then below average precip across the Southern Great Plains. And this is very concerning. Below average precip for the Four Corners area, the Colorado River Basin. They need water down there. They need water bad, and it's going to be impacting agriculture across the Southwest throughout the next year if they don't get that winter snowpack. Looking forward kind of into the wettest period of the year for South Dakota, April through June, our seasonal temperature outlook on the left, seasonal precip outlook on the right. There's not a lot of confidence in either above or below average precip or temperatures for our area, but definitely looking at the Southern Great Plains, looking warmer than average. And again, Southwest, Four Corners area, drier than average with some potential increases of precipitation over the Great Lakes region. That's really all I have for you. I'd be happy to take any questions afterwards. If not, again, I'm out of the South Dakota Mines, and so I just appreciate SDSU Extension bringing me in for this, and thanks for the opportunity to kind of give you a little bit of an outlook. There's my contact info. Feel free to call, email, tweet. There's my blog that I have. It's mostly fire weather related stuff, but I'd be happy to have any other discussions about weather or climate across the state. So thanks.